All right, welcome everybody. Let's do this. So for this part, in the last video, I made a mistake. Well, I did a typo here. This shouldn't be 25. This should be 26. And that's why when I was trying to solve the equation, it became a lot more difficult. So let's take a look over here. What's the general idea of what's happening? Here it says observe the system of equation. So when we have a system of equation, you have to create a visual, okay? So create a visual. You have to ask yourself, visually, what is happening, okay? So what is the visual of, visual of x minus y equals 6, right? What does this look like over here? This has to be a line, okay? What about this equation over here? This has to be a circle, okay? So let's visualize, let's try and sketch what this graph will look like. So here, how do you actually draw this circle? What's the center? It's 0. And what's the radius? The radius is, r is equal to, it's close to 5, right? Because square root of 25 is 5. So the square root of 26 is like 5.1 or something. So here, we'll just go 1, 2, 3, 4, 5. 1, 2, 3, 4. Oh, I'm sorry, a little bit above 5. So it should be like here. 1, 2, 3, 4, 5, and a little bit above, and 3, 4, 5 here. Okay. So this is your circle. Now, what about this equation over here? X minus y equals 6. Notice that this is the equation of a line, and we want to get it into y equals mx plus b. So let's get y by itself. So how do you get y by itself? If I do minus x, you get negative y equals negative x plus 6. And then how do you get y by itself? How do you get rid of that negative? Multiply both sides by negative 1, and y equals x minus 6. Okay? So we know y equals x minus 6, and what does that graph y equals x minus 6 look like? It kind of looks like this, something like that. All right, it's not a perfect graph, but this is what the graph looks like. And if you feel like you want to check to see what it looks like, well, let's see. If I go y equals, and I say x minus 6, and I graph it, notice that, oops, sorry, it's kind of hard to see there. Notice that this is the graph, right? And you see how it's not drawn to scale. It's not a perfect graph. But there's also, imagine that there's a circle here. So let's take a look. Here, what's happening? Notice you have a circle and you have 2 intersection points, or there should be 2 intersection points. So here, there has to be 2 solutions. There has to be a point over here, some x, y, and here there's another x comma y. There are 2 points that make the solution for that create the intersection for this circle and the line. So how do we algebraically do that? Well, let's take a look here. If I have x minus y equals 6, and if I have x squared plus y squared equals 26, okay? How do you actually solve for this system of equation? The general idea is isolate a variable in one equation, then plug in that variable into another equation, into the other equation. So what do I mean by here? I usually solve for x, and I get y by itself. So here, what am I talking about? Let's say if I have x minus y equals 6. All right, let's get y solo. Well, we already got y solo, right? What is y? Y is x minus 6. So the idea is, if you know y is equal to x minus 6, you're going to take this y equals x minus 6 and plug it in to the other equation. So here, if you know y is equal to x minus 6, anywhere you see y, you could plug in this x minus 6. So now we just have x squared plus parentheses x minus 6, the whole thing squared, right? This is your y. So you're just taking y and you're squaring it, and it equals 26. Now here, solve for x. Okay, well, how do you solve for x? How do you continue? Try and do it on your own. And notice that how many solutions are there? How many solutions are there? There should be 2, right? So you should have 2 values of x. So let's take a look. So this is x squared plus parentheses x minus 6, right? So this is x minus 6 times x minus 6 equals 26. So x squared plus, okay, so then how do you FOIL this, right? X times x, x squared. X times minus 6 is minus 6x. Minus 6x, positive 36 equals 26. Okay? Then what happens here? You have 2x squared minus 12x plus 36 equals 26. Now, let's see. How do you continue? Right? This is where a lot of people got stuck before. I want you to pause the video and really think about it. Like, how do I keep continuing to solve for x, right? So if you want to see how it's done, we want 0 on one side, okay? Why do you want 0 on one side? Or how do you know? Because remember, if I have some x squared, we want to get 0 on one side so we can factor, okay? So how do you, let's get 0 on one side. If I do minus 26 minus 26, now I have 2x squared minus 12x plus 10 equals 0. Now, how do you continue from here? Pause the video and try and figure out how do you continue from here. The idea is factor a GCF. So if I wanted to factor a GCF, what would it look like? Let me extend this a little bit. Notice that what's the GCF of 2, 12, and 10? It's 2. X squared minus 6x plus 5 equals 0. Then I can factor this. What 2 numbers when I multiply give me 5, but when I add give me negative 6? This is x minus 5, x minus 1 equals 0. Then I have what? X minus 5 equals 0, x minus 1 equals 0, x equals 5, x equals 1. Okay? Now, what does this x equals 5 and x equals 1 represent? Notice that for the graph over here, you see how there's a point of intersection over here? What is the x value of this point over here? It should be 1. What is the x value for this point over here? This should be 5. So now that we have the x values of the intersection, now we need to find the y values. So then how do you find the y values? Just plug in x equals 1, right? Plug in x equals 5. Okay? And that's how you're going to find the y value for the intersection points. And notice that which equation is best to use? Like, would you plug in 1 into the top equation or to the bottom equation? It doesn't matter, but what's the easiest equation to use? Either one is pretty easy. So let's just try the first one. If I say x minus y equals 6, right? So x is 1. So 1 minus y equals 6. Then negative y equals 5. Y is equal to negative 5. Okay? So it's saying when x is 1, y is negative 5. So over here, when x is 1, y is negative 5. And visually, doesn't that make sense? Because, like, look at the point. You see how it's like 1 positive, and it's just like, and it's like somewhere below. So you know this y value has to be negative, and it's that right there. And what about x equals 5? 5, all right, so then you just say x minus y equals 6. 5 minus y equals 6. Negative y equals 1. So now if negative y equals 1, y equals negative 1. And actually, wait a minute. That can't make sense. Hold on. What am I doing? 5 minus... Oh, wait. This is... y is negative 1. Okay, so then you see how this picture... You see y is negative 1. This picture is very bad. This picture should look something like this. It's something more like this. Right? This is a point and this is a point because y equals negative 1 is here. So I'm very sorry. The intersection isn't there. It should be something like 5, negative 1. Like that. Okay? All right, I hope this helped. What I want you to do is, for the next questions that, try and do question, where is it? Question 3. What I always want you to do is ask yourself visually what is happening, okay? And try and solve for this system of equation. If you want, you could go to desmos.com and plug in these two graphs into Desmos to visually see what's happening. Okay? Good luck.